Cool. My name's Alek Rollyson. Today I'm going to be talking to you about automating event log production and testing for detection purposes, or at the very least trying to make it a little less of a pain in the ass. A little bit about me. I work in FireEye Labs on detection for a product that we call the Threat Analytics Platform. If you're not familiar with it, it's FireEye's cloud SIEM offering. It's currently being coagulated into the greater Helix platform, so the name is subject to change. But going forward, if I say tap, that's what I mean. I'm not referring to something like a network tap. Well, this isn't a marketing talk. I'm not going to be talking about tap. This is general, like, boots on ground, making analysts' lives easier. Just a little bit about my day-to-day, just to give you a little color as to why this stuff became important and the impetus for some of these things. The bulk of what I do is create detection for event data. And when I say detection, it can be anything from signatures to analytics modules to generally just analyst experience within the product itself. So making the investigation experience better, or alert triage, or anything like that. And when I say event data, that can be literally anything a customer can send to us. Host-based data, Windows, Unix, Linux, network data across the board, application data. So if like somebody's sending us their even internal application data or something like a single sign-on platform. Cloud event logs, mostly work with things like AWS. Done a little bit with industrial control systems data. So we've done, about everything under the sun. If you can imagine it, we've probably touched it at some point. The other piece of what I do, or the more informal piece of what I do, is develop tools for our team to keep our collective heads from exploding. Because when you're working with thousands and thousands of event logs over a bunch of customers, you need all kinds of internal tooling just to make your lives easier. Anything from our test tooling to data validation stuff to a couple of the tools I'm going to be talking to you guys about today that we're going to be releasing. A little bit of background on our team. So we create detection for a wide variety of customers. So any new tap or Helix instance that gets deployed gets our entire rule set, which means that we have to stay as generic as possible, because we don't, in 99% of cases, we don't have the luxury of knowing what a customer's network is going to look like beforehand when they start dumping event logs into our platform, which means we have to stay as generic as possible and cover as many use cases as we can. And we can't be very specific because it needs to apply, like I said, to as many customers as possible. What that also means is we have to have a really robust quality control setup. At the core of that means unit testing for every single rule we put out. I'm going to talk a little bit more about our quality control here in a second. But this is really the core of why this talk was important, at least to me. Because when we go to create a rule, I have to be confident the rule is going to hit on what I think it's going to hit on, which means we need to be able to generate events that represent what it would look like in real life. I'm going to hit on this quickly, just because talking to some other people, I think some of the things we do internally might apply to other people's situations. Since we work for a vendor and building a rule set for a bunch of different customers, it may not necessarily apply to everybody since we're kind of a unique use case. But if anything in here looks interesting, you want to learn more about, just come up and ask one of us. There's a bunch of our team members here, and we can talk a little bit about it more. We run our content development basically like a small software development shop. And what I mean by that is we use Git for version control for all of our rules, and we use a simple topic branching methodology. So any new rule that we want to get added into the rule set goes into its own topic branch and gets put in a GitHub pull request. And we have a standard template for pull request that includes 3 different things: validation of the data, unit testing for every single rule that gets added in, and then historical checks. So validation is important, one, because we store all the rules in JSON format. It's a bunch of rule metadata, and then the query string, which is the actual signature itself, is stored in there as well. But one, is it valid JSON? 2, do these metadata fields make sense? We do some calculation between different fields that we can do automatically and not have humans do that. Second piece, like I mentioned, which is a really important piece, is testing. Anytime we want to introduce a new rule into the rule set, it has to have at least one positive test included with it, which at bare minimum says, I know this rule is going to match on what it's supposed to be matching, or what I'm intending it to match on. And the third thing is a historical check. Since we work in a SIEM and we have the luxury of being able to query, since we're in the cloud as well, we have the luxury of querying across our entire customer set to say, okay, for X number of retention days for each customer, we can say, I'm confident that this rule is going to not be false positive prone, because our query language is like 99% at parity with our rule language. I'm confident it's not going to be false positive prone. If it does have hits, they're true positives, and even if it does have some false positives, I think it's an acceptable level to push it out so all customers can take advantage of it. All that gets put into a pull request template, everything is peer reviewed, and since it's formatted in this nice template, a human can go through and look at it and say, okay, all the data validated, all the tests passed, the check looks good, we can merge this into master. And then when we go to publish a rule, we automatically revalidate the entire rule set and do a full unit test for the entire rule set before things go out. So we kind of have a double layer of protection there, which lets us publish basically on demand anytime we want and be confident that any rule push out is not going to be an issue. Just to talk a little bit about our pipeline, and this is a super high level representation of the pipeline because I only want to point out one particular thing here. Log sender, which we call communication broker. Customer sends logs to the log sender, which goes to a log receiver in the cloud, and then gets put into what we call our ingestion pipeline. And what's in parentheses there is what's important. Our rules get applied here, and then they get stored in the back end. And the reason why I want to point that out is a tip I have for you. If you have control of your ingestion pipeline and where you can apply detection, if you have the luxury of that particular case, apply your rules during ingestion because you can do one particular thing that's extremely useful later on. Any rules that match, you can then apply the rule metadata as data in the raw event itself. So then when it gets stored in the back end, it becomes searchable in your SIEM or log storage platform or whatever it is. So that way you want to say, okay, I want to see all these events that matched on a rule. You don't have to go to a separate alert database to see that because the rule metadata is actually in the raw event. And that's become more important when I talk about something else later down the line. So the overall problem is generating event logs for detection scenarios is just manually intensive and kind of annoying for a multitude of reasons. Getting logs from one place to another is kind of a pain in the ass. Recreating attack scenarios isn't necessarily trivial, especially with things like Windows host logs, which I'm going to talk a little bit more in a bit. Analysts having to maintain their own VMs, their own log syncing infrastructure, package configurations, all kinds of things. And there's a number of ways you can solve this problem. You could apply DevOps principles to this, things like configuration management and VM deployment with things like Vagrant. We chose to take a little bit of a different route and kind of centralize these things as services that any analyst could use so they don't have to run these things on their local boxes. So my focus today is going to be on network event data and Windows host data. I mentioned a bunch of other data sources before, and they all have their own unique problems in generating test events and getting them places, especially things like something like cloud logs, getting CloudTrail logs out of AWS into a SIEM parsed, and creating detection scenarios has its own challenges, but these are the two things I'm going to be talking about today. Starting with event logs. So the advice I have for you here is that Bro is your friend. If you were at Security Union Con yesterday, or even at some of the other talks today, you've probably heard a lot about Bro. Super easy to set up and parse, supports a ton of different data types. And even if you're not using it in production, even if you just have something like a proxy, just sending network logs into your SIEM or even just firewall logs, I still recommend you use Bro for generating your test data because I guarantee, especially if you just have something like a proxy, it's going to have a bunch more data than your proxy is, and you can always normalize that data in the back end. So let's say you have a really simple proxy setup. You just have method, domain, URI, port, and that was it. So if you generate your test data in Bro, as long as the URI field matches up to the URI field in your proxy logs, it doesn't really matter that you generated in Bro or not. You can always normalize that with parsing. And I say that like you can just parse it. I mean, that's sort of, and parsing is its own complete challenge, and outside the scope of this talk, and me saying just parse stuff is kind of like saying, in order to win, just don't lose. It has all of its own challenges. But as long as you do have at least decent parsing, those fields match up, it doesn't really matter if you're using Bro or not. So in this particular case, I'm suggesting you use Bro. Now you could have every analyst run Bro on their own box, which, like I said before, presents its own challenges with configuration management. If you have a bunch of analysts generating Bro data, do all their configs look the same? Are they generating data that's going to be consistent? So when they go to create detection, they would end up with the same sort of result. Or this is why we wrote this tool that we like to call BroCopy. It's a portmanteau of Bro, PCAP, and API. I included a GitHub link up there, which isn't live at the moment, but it'll hopefully be live in the next couple of days. Some internal things that just need to happen before it gets posted. But basically what it is that it's an HTTP REST API for mass Bro PCAP processing and tagging. And the tagging thing is the important here. So at a high level, what you can do is you can take a bunch of PCAPs. Let's say you have a dozen PCAPs from a particular malware family. You can submit those with a post request to BroCopy with a particular tag or whatever you want to call it. It then takes all those PCAPs in, runs Bro against them, stores all the logs locally, and submits them to a configured syslog server. So you can go from one post request to logs in your SIEM in one step, and that's it. Just to talk a little bit about the internals of BroCopy, but I'm not going to go too deep into this because it becomes a web app development talk. There's two pieces to it. There's the HTTP API on the front end, and all this is written in Python. It's a Flask app with one route, submit PCAPs. You post PCAPs to it, it queues jobs in Redis, and then the second piece of BroCopy, which we creatively called BroCopy Worker, is just a worker queue using a Python module called Redis queue. It takes all the submitted PCAPs through Bro, runs them through Bro, stores the logs locally, submits them to a syslog server. And there's a bunch of ways you can deploy this, and it scales really well. And this is kind of overkill for a simple, like, just get PCAPs into your SIEM situation. But if you have hundreds and hundreds of PCAPs or thousands of PCAPs like we sometimes do, this scales really well across the board because you can deploy it as a WSGI app for the API. And then for the worker, you can run as many workers as you want. We use just a daemon or a process control daemon called supervisor D. And you can run as many, like I said, because they're independent, like discrete workers, you can run as many as you want horizontally. I included configurations in the repository for all this. There's Unicorn, which is just a WSGI worker configuration, systemd service files for all this, a supervisor DINI file for running the BroCopy worker. So all that's in the repository. And there, if you want to look at deploying it in like a more consistent manner. So here's what a request would look like using curl. You have a PCAP called foo.pcap, and I want to tag this with the tag evil. So you post it to BroCopy with the file, and then in the form data with tag equals evil, and that JSON blob at the bottom is a return that you would get. We queued a job, here's the files you gave me, here's the tag you gave me, here's the job UUID. So when the worker runs, this is how it stores it on local disk. So you have the overall configured jobs directory. Then underneath that, you're going to have a bunch of folders that are named after the job UUIDs. And underneath that, you have two folders, logs for the logs stored locally, and then PCAPs for all the PCAPs that you gave it. And so when I say tagging, this is what I mean and what it's doing. So the first line there is a syslog header. You got the syslog priority number, the timestamp, and the highlighted piece is your tag. Normally what this is the syslog hostname field. And since this is test data and it's not coming from an actual system, it's a PCAP that you submitted, we don't really care what the syslog hostname is, so we can just take advantage of this and submit the tag here. So for us, what we parse that to is a field we call raw message hostname. So if I submit a PCAP in, I can then go back and say, okay, show me raw message hostname equals evil, and boom, I've got all the logs for that PCAP I submitted. And the reason why we did this is because it doesn't require any additional parsing. You could do something like adding an additional bro field, but for us, since we work in like a pretty large product, we wanted to take advantage of a field that was already parsed. In this case, it's a vestigial field anyway, because we really don't care what the syslog hostname was. Now what you can do with this, and my tip here, is that you can further subdivide your input by appending tags to your initial tag, and we do this on client side. So like a use case here would be, say you've got X number of PCAPs from some malware family, but it's a bunch of different variants. And you want to be able to say, yes, I want to tag all these with this malware family, but I want to be able to tell which PCAP was which. So like we have some client-side scripts which I haven't released because they're a bunch of like internal idiosyncrasies related to them, but really all they are just wrappers around the Python request module. So I go in and say, I want to submit the BroCopy with the tag evil 12 PCAPs. And then what the client does is it just appends, like for us, it's like a six-letter hexadecimal value, and then submits it. So when I go in and I can say, okay, this is evil-1 or evil-2 or evil-3, and so it's all subdivided by the PCAPs that you gave it. And this is especially useful if you have the capability to do prefix searching in your log storage platform. So if I want to see an individual PCAP, I can go, okay, show me raw message hostname evil-1, or if I want to see all of them, and look at them all at the same time instead of by an individual PCAP basis, I can just show me raw message hostname evil star, and it'll give you all of the PCAPs you submitted, not just like granular by one. So this is a bunch of different use cases. For us, quick detection verification. So even if it's us or another team or a sales engineer comes to us and they say, hey, I got this PCAP of this malware, do we detect this? Like, well, just post the PCAP to this API, it'll show up in our test Helix instance, and it's either going to match something or it's not. So it's a quick way one post request, logs come in, detection matched against it, shows up, we can search it, and that's all that we had to do. Gives you reliable and reproducible test production because you're doing it all in one place. Since your analysts are using the same API with the same bro configuration, you're going to get the same result every single time. And because it has, you can give it a unique input, which is then tagged on the output, you can use it as a building block in further automation. So like a use case here would be scrape a bunch of PCAPs from an RSS feed, say like malwaretrafficanalysis.net, automatically post them all to BroCopy with some kind of derived tag, stores it in the back end, then whatever your automatic job is can go and search for those results and do things like build reports. So you can automatically just point it at your RSS feed, and every time a PCAP comes in, what logs do we see, or what logs does Bro put out? Do we have any detection on this? And this is why the ingestion detection, what I talked about earlier, is kind of important, because if you have it as searchable metadata, you don't have to go calling in another alert database to say, okay, is this log in an alert? It's all just metadata there in the raw event itself. And even more useful than that, you can say, okay, what out of this PCAP didn't match anything? So you can do the reverse. Whereas if it was all stored in an alert database, you'd say, okay, here's the logs in the alert database. Now you have to do a diff against what all actually came in. So we've done that, automated away some of the pain points for network logs. Let's do the same thing with Windows logs. So host logs in general are just more of a pain. They require more initial setup. For Bro, I mean, you just apt-get or yum install Bro and run PCAPs through, and boom, you got logs. With Windows logs, you have to actually set up a VM, set up some kind of log forwarding configuration. You have a bunch of group policy settings to get all the event logs that you want, or installing sysmon on it, something like that. Just generally a lot more overhead in maintaining VMs, and there's a lot more options for configuration and delivery. Just my 2 cents on the host configuration itself. I mentioned sysmon before, and I'm kind of beating a dead horse at this point, but sysmon is great in the same reason that Bro is great. It gives you a ton of data. And again, even if you're not using it internally, if you're just relying on like event ID 4688 process execution events, even if you're generating sysmon in part of your test events, as long as the image field from a sysmon event maps to the process field for 4688 events, it doesn't really matter what was generating it as long as the parsing matches up. I suggest you use NX logs as sender for a very specific reason that I'm going to talk about in a slide or two. But other than that, they got a free community edition. It's easy to set up. It basically just works. It's easy to configure. The third piece is send your logs in JSON format. In a lot of cases, especially with Windows events, you're going to get a little bit higher verbosity and things you might not see in tab delimited, just normal syslog events. And the other reason is you're not a parsing masochist. Nobody loves parsing tab delimited syslog fields. It just sucks. And nobody's really going to turn down pre-serialized data. So let's automate some of this away using Cuckoo. So we wrote this module that we like to call tag host. And what it is the Windows auxiliary module that it requires NXLog to be installed, which is why I mentioned it a second ago. And what it's going to do is it's got a dummy variable in the in the NXLog config. So it's going to take a predetermined tag, same way BroCopy did. So you're going to say, okay, run this analysis. This is the tag that I want to come from the event logs. It's going to rewrite the dummy variable in the NXLog config with whatever tag you provided it, restart NXLog, and now what happens is any new event coming out of that system is going to have a host name of whatever the tag it was you gave it. So this way you can run a sample in Cuckoo, give it a tag. If you have event forwarding set up out of your Cuckoo guests, they'll automatically send it to whatever sender you configured it to, and if you have that automatically going into your SIEM, you're going to have tagged by host name for each analysis run. So here's an example of just a simple API request. It looks identical to the BroCopy one. You got your file, just called file, and then the way this works with tag hosts is Cuckoo has what's called an options field for every analysis run, and so what it's going to look for is this tag underscore host key, and the value they give it is going to be whatever tag you want to your analysis run to be tagged with. And so for us, the hostname field that comes in Windows logs is parsed to a field just called hostname. So if I tag it with the tag evil, and I want to go in and say, okay, show me all the logs from this analysis run, I can just say hostname equals evil, and boom, I got all the Windows logs from that particular Cuckoo run. The use cases here are basically the same as BroCopy. Quick detection verification. You can go from sample to Windows event logs in your SIEM quickly. Reproducible and reliable test production, because these analysts isn't running their own Windows VM with the log forwarding setup. You just set up a bunch of VMs in Cuckoo with this. They can get event logs out. And building block for further automation the same way with BroCopy. You get a feed of samples coming in, can tag them, run through, store it in your SIEM. Since you controlled the tag and it's tagged on output, you can automatically search for that and do all kinds of whatever you want to do after that. Just a quick tip here. Let's say you have a bunch of commands for like an IR report. So attacker got in a box and ran these 12 commands. Could spin up a VM and manually run these all themselves, or run all these commands themselves, or toss them all in a batch script and throw them at Cuckoo. It's going to go through, execute the batch script, run each of those commands in sequence, and you're going to get event logs just like somebody was on the box running those commands themselves. So, aside from the tools we released today, how else do we make our lives easier? By sharing. So, this is in the works. This isn't being released yet. That we're working towards a release, just going through some internal processes to figure out the best way to do it. So for our team, we wrote a ton of what we call Windows methodology rules, and basically it's just like general Windows behavior from all over the board. If it's like, process relationships, like this is an event log from when PowerShell gets called from an Office process, or when someone deletes prefetch, down to like things like just normal operational behavior, like adding someone to like a privileged group, or anything you can think of. So anything that we had a public reference for, if it was based on a blog or based on a tweet or based on a presentation, we include all that as metadata in our rules. So what I wanted to do was take all of these and basically publish the test events for them, not the rules. But so what I think we should build is this public reference of what a Windows event log looks like when something happens. So you've got things like Ultimate Windows Security, which like basically lays out what each event ID looks like. But there's nowhere to say, okay, here's the test data. I can spit this into my SIEM. It's a recreation of what it would look like in production. Basically, you'd have to go and do it yourself. So there's no reason, especially for things like operational stuff, is like, okay, what does the actual Windows event look like for a failed login to a non-existent account? So there's no reason we can share that kind of things, especially if like a bunch of us are reproducing the same stuff. So what we've done is basically taken all those positive tests and organized them by directory, and the directories are topic directories, whether it be like lateral movement or privilege escalation or PowerShell related things or process relationships, and basically just building this corpus of example Windows events. And like I said, I'm still working on getting this published. Hopefully I'll have something in the next week. It probably will end up on the FireEye GitHub as well. If it doesn't, we'll figure out somewhere else for it to live. When it does come out, we're going to hopefully continue releasing things as we find them. If we see tweets, it's like, okay, that's interesting. If John Lambert tweets out, maybe you guys should be watching for long app data path directories. Okay, we'll go create a Windows for that, stick it, add it as a positive test for whatever rule we might create, and then since it's based on public reference information, just publish it to the public GitHub. This is just an example of some of the stuff that would be released in this. There's about 100 of them right now. I probably can go through and find a bunch of other ones for that don't necessarily have public references right now, but I'm sure they exist. But yeah, thanks to all these guys. These guys either worked on our team at one point or still work on our team and either generated some of those reference events I was just talking about or helped me develop some of the tools I was talking about earlier. So yeah, thank you to these guys, most of which I think are here at the conference except for Patrick. So with that, my slides are at this link. They're just HTML. So it works straight off the site, or you can just clone a repo or ask me questions or whatever. So with that, you guys have any questions?